Fusion Mobile, quality e-learning experience on the go.
The next topic is soil profile. Soil profile, by definition, soil profile is the vertical section of the soil that shows the arrangement of different types of soil in horizontal layers, and each layer is called horizon. I'll take it again. Soil profile is the vertical cut or vertical section of the soil showing the arrangement of different types of soil in horizontal layers, and each layer is called an horizon. Now, in a complete soil, we have 4 horizons: horizon A, B, C, and D, plus a level of organic matter on top of the soil. So if you have soil and then you dig down into it to look at what you have inside the soil, this is what you are going to have. You are going to see that in a complete soil, the soil is broken to 4 compartments, and then you have a level of organic matter on top. The level of organic matter on top is, this organic matter is formed from plant and animal remains which are broken down and decomposed and now settle on top of the soil, which aids the nutrients or the mineral, which aids the proper growth of the crops. Now, as we move down from the organic matter, you get to the topsoil. The topsoil is also called horizon A. That one is very close to the surface. This is the one that contains very tiny particles. Very tiny particles. The particles are well broken down and well weathered. It's well broken down. Then when you go from there, you move to the next one stage, which is horizon B. The particles here are bigger than the one in horizon A. They are bigger in horizon A. Then you move down, you get to horizon C. Horizon C particles are bigger than horizon B. Horizon B is called subsoil, where horizon C is called parent material. Then when you go to the bottom, that's horizon D. The particles are bigger, are the biggest in size. Look at the particles are biggest in size. The rocks are unweathered, they are not broken down. But the one on top, they are the most weathered, most broken down horizons or layer. Why horizon D is the unweathered, unbroken down horizons. Now, as we move from horizon A down to horizon D, there are some changes in the pattern and the behavior of the profile. There are some changes. Now, we can see these changes. Number one change you are going to find is the color. Changes in color. Color will change. As we move from horizon A down to horizon D, the color becomes lighter. Because up here the color is dark, while here the color is very light. The reason for the darkness in color is because of its proximity of horizon A to organic matter. Organic matter is dark, it's black in color, and so the horizon that are close to it will be black. As we move further from organic matter, the color becomes lighter. So the first changes you are going to find will be changes in color. Then the second change you are going to find is changes in mineral matter, in organic matter, in fertility level, changes in fertility level or organic matter. The horizon A is the most fertile horizon because of its proximity or closeness to organic matter. The organic matter here will influence topsoil. That's why topsoil is of concern when you are planting crops. It has to be very fertile. As I'm moving from topsoil down to subsoil down, then the organic matter level begin to go down because they are far from topsoil, from the organic matter layer on top. The third one is particle sizes. Particle sizes. As we move down the horizon, the particle sizes increase. So at the horizon A, the particle size is very green, very tiny, very tiny. But as we moving down the horizon, the particle sizes become bigger. Why? Because as you are moving down, you are moving to the rocks that are undisturbed, rocks that are not broken down. So the most weathered, the most broken down horizon is horizon A. The least broken down horizon is horizon D, which perhaps many occasions are not even broken down at all. So these are the changes that are observable as I'm moving down the horizon. The color, the fertility level, then the particle sizes of the of the particles. So this is soil profile. Now we can look at why do we study soil profile. What are the importance of soil profile? Yes, number one is that the soil profile enables you to know the level of fertility in the soil. It has to determine the fertility level of the soil. If the soil has a very thick and rich topsoil, that soil is very good, that level. If a lot of organic matter content are located on top, then you know it's very fertile. But if there's organic matter level and the topsoil is very light, it's not quite thick enough, then you will know that the fertility level is low. Now, the second one, to know the type of crops to plant. Every plant requires certain types of soil and certain types of profile. So when you observe, maybe the topsoil is so small and then the particles are big, then you know the type of crops you're going to plant there. So or the other way around, the level or the type of profile you have will justify the type of crops you're going to plant. Then it also can determine level of drainage and aeration. For instance, if a topsoil is lightly packed, it's not tightly packed, it's not so fused together, you know that drainage will be easy, and the aeration can the soil will be very porous, the air circulation will be very easy. No, it also helps you to know easy percolation of water. Let's talk about the soil structure. You know, this other one level talks about the soil texture. When you know the aeration and drainage, but percolation of water, we talk about the soil structure. If the structure is so tight and fused together, water may not percolate from top down, especially maybe in a clay soil. But if the soil particles are loose, like in loamy and the clay and the sandy, the water can still go through. The same thing happens to vegetation of roots. If the soil is not tightly packed, if it's loose, roots can easily go through it. So these are reasons why we study soil profile.